and got myself a new microphone. I wasn't terribly pleased with my audio quality on some of those videos last week, so hopefully this will make things a little better. I don't know. If you guys can't hear me, just, you know, unmute yourself and let me know. Hopefully I can adjust something. But it seemed like it was working a little better. Okay, so let's dive in. On Friday last time, we finished off, I spent the last 15 minutes or so talking about matrices. So I introduced what a matrix was, and I told you that somehow we're going to use those to solve systems of equations. And so today I want to go more into that. So let me just remind you that a matrix was just a rectangular array of numbers, and that's pretty much it. And the last thing we did was we talked about augmented matrices, where I gave you a system of equations, and from that we got a matrix. So let me throw an example of that up on the board just to jog your memory a little bit. So if I give you a system of equations, say this. Let's do two equations here. Here's a nice system of equations: 2x minus 3y equals 0, negative 4x plus 5y equals 2. We learned on Friday how to get what we called an augmented matrix for this, where I'm just going to encode all this information in a matrix. And so it went like this. I draw my little brackets for a matrix. I put in a vertical bar somewhere where this represents the equal sign. And so to the left of the bar, I'm going to write the numbers, the coefficients of the variables. And I'm going to since I have my variables lined up nice, I have sort of like an x column and a y column, and I have a row for each equation. So I'm going to have 2 rows and 2 columns to the left of the bar, and then I'll have another column to the right of the bar for these numbers. So the numbers would just fill in like this. My top row would just be this first equation, 2, negative 3, 0. And the second row will just be the second equation, negative 4, 5, and 2. So this is how we could write down a matrix, an augmented matrix. And then I'll write that word up here. The augmented matrix. Augmented matrix for this system of equations. Okay. And so you're going to be doing this a lot, going from system of equations to matrix. Maybe I'll point out really quickly that you can go the other way. If I give you a matrix, I don't know, I'll make one up real quick. 1, 2, maybe we'll just do this. Here's a matrix. I wrote it as an augmented matrix. You can go from augmented matrix to system by, again, just sort of reinterpreting what these numbers are supposed to mean. So remember, each of these columns to the left of the bar represents a variable. So this is like an x column. This is like a y column. And then that bar represents equal sign. And then this is on the right of the equal sign. So I can sort of reinterpret this matrix as a system of equations, and that would give me this. If I call my variables x and y, this would give me the first equation to be x for the 1 plus 2y, 2, and then it'd be equal to 3, because again, the vertical bar means equals. And then the second equation would be 4x plus 5y equals 6. Okay. So it's helpful for us to be able to go both ways. Either I could give you a system of equations and you write down the augmented matrix, or if you're given the augmented matrix, you need to be able to write down a system of equations that would correspond to it. And this is just how to do it. Okay. So matrix is just some fancy way for us to encode the information of a system of equations. That's all it is. Okay, so now that we can do this, what are we going to do with this matrix? Like, why do we want a matrix beyond just encoding it? And here's the idea, and then I'm going to show you sort of how we're going to approach this sort of idea or goal. Here's our goal. I'm going to give you a system of equations. You're going to get an augmented matrix. We're going to turn the augmented matrix into a simpler one. I'll give you some system of equations. You write down the matrix. It's some crazy matrix. I want to make it into a simpler matrix that's easier to understand, because then when I turn that simpler matrix back into a system of equations, it'll be a simpler system of equations that I could solve. In fact, if we do it right, maybe the simpler system of equations will actually just be the solution. It won't be, we won't have to solve anything anymore. It'll basically just solve it for us. So we want to sort of learn a method or a strategy to make this a little more precise. Yeah, this is sort of our goal right now. We want to figure out how to actually make this a reality. Yeah, okay. So to do that, we need to be able to do things to our matrix to be able to transform it. And so those are what we're going to call row operations. These are the things that I'm going to be allowed to do my matrix, and I'm not allowed to do anything else. So these are the only things that you'll be allowed to do to a matrix. And they're grounded in, they're grounded in reality, I'll say. Some of these might seem like, where are these coming from in a second? And I'll show you that they basically come from the things that we're already allowed to do to a system of equations. So they're not actually anything new. I'm just sort of encoding them in this matrix language. Okay. So for example, let me give you, let's give it a little system of equations here just to deal with. Maybe, okay. Let's write it over here. I'm just going to write a simple system of equations. Okay. We're not going to solve this system. I just need it to demonstrate. Here's a simple system of equations, 2 equations. And let me write another system of equations. And I'm going to ask you guys a question about it. So compare those 2 systems of equations. And are they different? And the question is, if they're different, how are they different? And does it really matter that they're different in that way? So how are they different? And hopefully what you guys notice is that the only difference between these 2 equations is that I just wrote the equations in a different order. Yeah, I just swapped the order. And the question I'd want to ask you is, does swapping the order of the equations change anything? I mean, if I just write them in a different order, is that going to change the solution if it exists? Is that really going to affect anything about the system at all? And the answer is no, it's not. They're the same equations. All that matters is that I have the same equations. I wrote them in a different order, sure, but they're the same equations. So these are like these are like the same systems. Yeah. There's nothing different about them other than that I wrote the equations in a different order, but that doesn't matter mathematically. So when I write a system of equations, I'm kind of allowed to swap the order of the equations. And that's going to be helpful for us with a matrix because our first row operation is going to be swapping the order of rows. So here's our row operation number 1. There's going to be 3 of these. Here's number 1. We are allowed to swap any 2 rows of a matrix. So one thing we're allowed to do is swap the order of 2 rows. I can just take 2 rows and interchange them. Again, that's because the rows of a matrix correspond to the equations in a system of equations. And as we just saw, it doesn't matter what order I write the equations in a system. So it really doesn't matter what order my rows are in either. So I'm allowed to interchange my rows. Sometimes this will be helpful for us. It'd be a useful trick. So, instead of just writing 1, 2, 3, 4, 5, 6, I could instead write this like this. And all I've done is just swap those 2 rows. Yeah. It doesn't matter how big your matrix is or how many rows there are. You can always just take 2 of the rows and swap them. Always. Okay. So there's this question of notation because you guys are sort of expected to show your work as you work through these. And so I always drew this arrow from here to here. You might write, I don't know, you guys can get a little creative with your notation here. It's helpful if you can explain to me what you're doing as you show me your work. And so like for this, maybe I'd write something like row 1, little arrows, row 2 or something. I don't know, because I swapped the first row and the second row. I might notate it like this. You might just write words like swap those two rows or something. I don't know. But when you show your work doing these problems, it's helpful to just kind of explain what you're doing at each step, because it can get sort of complicated. You're going to see that some of these have several steps. And so it's helpful, help me out, help me understand what you're writing. Just tell me what you're doing somehow. So I might use these symbols sometimes, R and then the little number representing which row I'm talking about. So I might use that sometimes. And if you're never sure what I'm writing, just unmute your mic and let me know, and I will answer your question. Okay. So first row operation is we are allowed to swap rows. We can interchange any two rows. Okay. That's sort of the easiest one to get our hands on. There's another one that's not so bad. And this goes like this. I'll just introduce it this way. We'll say row operation number 2. So we know when we solve an equation, I'm always allowed to multiply or divide both sides of an equation by a number. The same thing is going to be true here because a row just represents an equation. So if I can multiply an equation by a number, I can multiply a row by a number. So this next row operation is multiply, or if you like, divide any row by any non-zero number. Okay. So the only catch here is you can't multiply or divide a row by 0, because you can't divide by 0 anyway. That just doesn't make sense. And if you multiply a row by 0, everything in the row will become 0, because anything times 0 is 0. And then that's just not helpful anymore. You've killed too much information. So you can't use 0, but you can multiply or divide by anything else. And so to make this explicit, let me just show an example of what this looks like. Here's another matrix. I mean, I'll just use the same one to illustrate. And I don't know, let's multiply the first row by -4 or something. Just pick a number, just as long as it's not 0. I'm going to pick -4 suggestively. So we're going to multiply the first row by -4, which means that every single number in this row will get multiplied by -4. So when I say multiply a row, I really mean multiply everything in that row by the number. So let's multiply everything in this row by -4. So I'll get 1 times -4 is -4. 2 times -4 is -8. And 3 times -4 is -12. And then I will not have done anything to the second row, so it stays the same. Okay. And so here we go. Here's our new matrix. Multiplied the first row by -4. And to notate this, maybe what I might use is this symbol. I might just write the number that I'm multiplying by times R1 because I multiplied the first row. Yeah. Again, you might come up with another way to notate this, or you might just say in words what you're doing, but I'll probably use symbols like this when I show my work. Okay. So you can multiply or divide a row by a number. I'll warn you now, with this division, you're probably going to come into situations where you divide a row by a number and you're going to make fractions. And that does not mean you're doing anything wrong. It's just part of, this is just sort of part of the experience. You're going to deal with fractions. So again, if you're a little rusty on your fractions, I posted a guide on Canvas, a PDF guide. You might take a look at that to sort of refresh on some of the fraction operations. But we want to be able to deal with fractions in this class. So don't be alarmed when they start popping up. Okay. So we have 2 row operations so far. One, I'm allowed to interchange 2 rows. And secondly, I'm allowed to either multiply or divide a row by a non-zero number. Those are my 2 row operations. And these both come from what we are allowed to do to equations in a system of equations. Okay. So finally, there's one more row operation that I need to tell you about. And I'm going to go ahead and just write it down, and then I'll show you an example, maybe try to explain where this is coming from. So here's our last row operation. And I always have to think about how I want to word this. I think I'm going to do it this way.